All right, let's dive into one of the biggest, most mind-bending questions in all of science. Where does time even come from? Today we're going to look at a super bold, really ambitious new theory from a physicist named David Deutsch that completely flips our whole understanding of the universe right on its head.
So to even get started, we have to ask a question that, it sounds kind of absurd on the surface, but it's at the absolute heart of modern physics. Does time, the way we feel it, the way we experience it every day, does it actually exist in some fundamental way?
And look, this isn't just some philosophical thought experiment. This is a real, live debate happening in the physics community right now. It might be a great excuse if you're late for a meeting, sure, but way more importantly, it points to this massive problem sitting at the very core of how we understand the universe.
So, what is this problem? What's the big headache? Well, it's a fundamental clash, a real showdown between our two greatest theories of modern physics, and it all boils down to the fact that they see time in completely different ways.
I mean, the conflict is just so stark. In Einstein's general relativity, time is just another coordinate, like length or width. It's flexible, it's relative. There's no single universal now. But then you jump into the quantum world, and whoa, things just go off the rails. The whole idea of a single flowing time just shatters. You can apparently have several different times all at once. And if you're sitting there wondering what that even means, well, you're not alone. That's the headache. Nobody really knows.
So, how do physicists usually try to get around this? The standard approach is basically to build their own clock. They look at how matter changes relative to other matter. Think of a pendulum swinging back and forth, or an atom vibrating, and they use that consistent change to sort of bootstrap the concept of time. In other words, they define time by the things that are changing within it.
But what if that's the wrong way to look at it entirely? This is where physicist David Deutsch and his collaborator Chiara Marletto come in with a completely different and, frankly, an incredibly audacious idea. It's called Constructor Theory, and it basically throws the entire traditional physics playbook out the window and starts from absolute scratch.
Now, this is the crucial point, the thing you really gotta get. Constructor theory isn't about what things are, particles, forces, fields. It's about what things can do. The fundamental laws of nature, in this view, are just a set of rules about which tasks or transformations are possible in our universe and which ones are totally forbidden.
And this is why the whole approach feels so, well, weirdly backwards. For hundreds of years, physics has been all about reductionism, breaking things down into smaller and smaller pieces to find the fundamental truth. Constructor theory does the exact opposite. It starts at the top with the highest level rules, what can and can't happen, and then it derives everything else from there. It's a totally non-reductionist way of looking at the universe.
Okay, so let's get into the nitty-gritty of how this theory is built. At its very heart are the things that actually perform these tasks. They're called constructors.
So what in the world is a constructor? Well, think of a chemical catalyst. It goes in, it makes a reaction happen, causes a change, but then it comes out totally unchanged, ready to go do it all over again. Or think about a ribosome inside a cell, busy building a complex protein. The ribosome is the thing making the change happen, and then it just moves on to build the next one. That's a constructor. And the key thing is, they have to have some complexity. A single little elementary particle can't be one.
Okay, so we have tasks and we have constructors. Fine, but how does any of this solve our big-time headache? How do you build a universal clock from a theory that, by its very design, doesn't have one to begin with?
Right, here's the puzzle. You might think, oh, that's easy, just find a constructor that does the same thing over and over again, like an oscillation. But how would you know that each cycle takes the same amount of time? For all you know, it could be slowing down over billions of years, kind of like a Windows update that seems to take longer every single time, and you'd have no way to tell. You can't use a clock to build a clock. It's a classic chicken and egg problem.
And this brings us to the theory's really elegant, if very abstract, solution. It identifies the most fundamental, the most basic task possible. It's called the null task, and all it is the act of a constructor turning on and then immediately turning off, without actually doing anything else. It's the shortest possible action, the absolute bare minimum event that the universe allows.
So the theory then says, what if you group all of these possible null tasks together? This giant group, this collection of doing nothing, represents the fundamental, shortest possible unit of change. So by measuring all other, more complicated tasks relative to this baseline of doing nothing, you've effectively created a universal measure of change. And what is a universal measure of change? Well, for all intents and purposes, that's time. So, is this a brilliant breakthrough that redefines reality as we know it? Or is it just too abstract to even be useful? That is the big question.
And there is a major criticism. A lot of physicists look at this and say, wait a minute, this whole argument seems a bit circular. To even define a task, a process that runs from a start to a finish, don't you have to already assume that time exists? It's a really powerful objection.
And this brings us to the final provocative takeaway. When you try to put this absolutely mind-bending idea on the scale of scientific breakthroughs, well, it's not so easy.
And honestly, this quote from physicist Sabine Hossenfelder just captures the whole situation perfectly. Constructor theory is so radical, it's so different from everything else out there, that it's either a truly revolutionary insight into the deep nature of reality, or it's a complete dead end. It is the definition of a high-risk, high-reward idea. And for now, all we can really do is wait and see which one it turns out to be.